Today we're going to look at computing with scientific notation. So we've already talked about scientific notation. We've already talked about multiplying and dividing monomials. We're going to combine that together for this lesson, and we need to remember those rules, okay? So for number 1, we have 7.2 times 10 to the third, and then multiplying that times 1.6 times 10 to the fourth. So we can kind of rework what we are multiplying here, all right? So I'm going to multiply my numbers together, 7.2 times 1.6, and I am just multiplying it as 72 times 16. So doing that multiplication, 6 times 2 is 12, carry the 1. 6 times 7 is 42, plus 1 is 43. Put our 0 placeholder. 1 times 2 is 2. 1 times 7 is 7. And we add, we get 11.52 when we apply in our decimal values, okay? So we have 11.52 times 10 to the third is our first one, times 10 to the fourth is our second one. So this really is 11.52 times, well, when we're multiplying numbers with the same base, we add the exponent. So 3 plus 4 is 7. Here's the only problem. Right now, this is not in scientific notation because our whole number here is greater than 9. It's a 2-digit number, right? So what I'm going to do is I'm going to move my decimal over 1, which essentially means I'm multiplying it by 10. So we have 1.152, and it's going to be times 10 to the 8th instead. Number 2, let's do the same thing here. So I'm going to take my two numbers, 8.4 and 2.5, and we're going to multiply those together. So 84 times 25. 5 times 4 is 20, carry the 2. 5 times 8 is 40, plus 2 is 42. 2 times 4 is 8. 2 times 8 is 16. We add, and we get 2100. Put in our decimal values, it's 21. So we are doing 21 times our first power, which is 10 to the second, times our second power, which is 10 to the 6th. So 10 to the second times 10 to the 6th is really 10 to the 8th. So it's 21 times 10 to the 8th. But again, this number here is not proper scientific notation because our decimal is here. So I'm going to move the decimal over once to make it 2.1 times, and we're going to add 1 to our power, 10 to the 9th. Let's try one more with multiplication. Taking my numbers, 2.63 times 1.2, so 263 times 12. 2 times 3 is 6. 2 times 6 is 12. Carry the 1. 2 times 2 is 4, plus 1 is 5. 0 placeholder. 1 times 3, 1 times 6, 1 times 2. Add them together. 6, 5, 11, 3. And there was 1, 2, 3 decimal points, so it should be 3.156. Okay, so we have 3.156 times. Our first power is 10 to the 4th. Our second is 10 to the negative 3rd. We are adding our exponents. 4 plus negative 3 is just 1. So 3.156 times 10 to the 1st. This is in scientific notation, so I don't have to move anything. I can leave it as is. All right, let's look at division. We're gonna split it up just like we did with multiplication. We're gonna look at our numbers and we're gonna look at our powers. So this really is 25 over 5 times 10 to the 5th over 10 to the 2nd power. So 25 over 5 simplifies to 5 times 10 to the 5th over 10 to the 2nd. We subtract 5 minus 2 is 3. 10 to the 3rd. And that is in scientific notation because it's a single digit number here. We are good. Let's do it again for number 5. Splitting it up, our numbers, we have 7 over 3 times our powers, 10 to the 9th over 10 to the 7th. So this one was nice because it divided out to a whole number. Here, 7 over 3, that's not going to be a whole number. We're actually going to divide. Let's do some long division, our favorite. 7 divided by 3. 3 goes into 7 twice. We get a remainder of 1, so we add a 0, bring it down. 3 goes into 10 3 times. Get a remainder, add a 0, bring it down. 3 goes into 10 3 times. This is going to keep going on and on forever. So our number is 2.3, repeating, times 10, well, 9 minus 7 is 2. So times 10 to the 2nd power. And this does fit what we need for scientific notation, so we are good. All right, adding and subtracting. So we did multiplying, we did dividing. Let's look at adding and subtracting. So we've got 6.89 times 10 to the 4th plus 9.24 times 10 to the 5th. Kind of like fractions. We need common, like in fractions, you need common denominators to be able to add. When we're adding these, we need them to have common powers. If they don't have common powers, we can't just add them. So what I'm going to do is I'm going to convert so that they have the same. So I'm going to move this decimal once to the right, which is going to make this have a power of 4. So essentially, we are doing 6.89 times 10 to the power of 4 plus 92.4 times 10 to the power of 4. Now they have like terms, or however you want to think of it, and we can add. So I am just splitting it up and doing, I'm going to write it here, 6.89 plus 92.4. Let's do this, plus 92.4. And all of this is being multiplied by 10 to the 4th. So we get 99.29 times 10 to the 4th. 99 is not proper scientific notation, so I'm going to move my decimal back to the left, and that means this 4 is going to become a 5. So it's going to be 9.929 times 10 to the 5th power. All right, number 7. We've got 10 to the 9th and 10 to the 2nd. Big difference here. So what do I want to move here? I'm going to move this one and change it into 10 to the 2nd. That's a difference of 7, right? So if we have 1.263, I need to move this 1, 2, 3, 4, 5, 6, 7 times. So we really have 1, 2, 6, 3, 0, 0, 0, 0 times 10 to the 2nd minus 1.9 times 10 to the 2nd. And we can subtract. So I'm going to take this number and subtract this number. So let's set that up. 1, 2, 6, 3, 0, 0, 0, 0, minus 1.9. We got to do a lot of borrowing. So borrow all the way from the 3. 3 becomes 2. This becomes 9. 9, 9, 9, 10. 10 minus 9 is 1. 9 minus 1 is 8. 9 minus 0. 9 minus 0. 9 minus 0. 2, 6, 2, 1. Times 10 to the second. Now you got to convert back because this is a really big number, and that is definitely not scientific notation. So we're going to move our decimal once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. So 1.2629998.1 times 10. We moved it 7 times, so times 10 to the 9th. Let's practice 2 more like that. Number 8. Difference here is we have one that's in scientific notation and we have one that is not. There are 2 ways that you could go about adding this, okay? We can either turn this into your standard number form and add, okay? But then we'd have to go back and put it in scientific notation because that's what we're practicing. Or I can change this 593,000 into scientific notation. I'm going to convert this. So this is going to be 5.93 times 10 to the 1, 2, 3, 4, 5th power. And we are adding 7.89 times 10 to the 6th. Now we have to remember we want them to have the same power. I always change it to the lower power. So the 6 I'm going to change to a 5 by moving this decimal over 1. So we are adding 5.93 plus 78.9, and it's going to be that times 10 to the 5th. So we add, we get 3, 8, carry the 1, 14, carry the 1, 8. So 84.83 times 10 to the 5th. Again, this number here is not in scientific notation, so I'm going to move my decimal once to the left, which is going to change that to a 6. So this is going to become 8.483 times 10 to the 6th power. One more. I'm going to convert my standard number into scientific notation. So the 7.83 times 10 to the 8th is going to stay. We are subtracting 1.161 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. I always like to convert to the lower power. So I'm going to change the 8 to a 7, which means I'm going to move this decimal once to the right. So we have 78.3 times 10 to the 7th. We are subtracting 1.161. Kind of crammed that in here. So when I'm subtracting, I need to borrow. 3 is going to become a 2. This 0 becomes a 9. This 0 becomes 10. 10 minus 1 is 9. 9 minus 6 is 3. 2 minus 1 is 1. 8 minus 1 is 7. 7 minus 0 is 7. Times 10 to the 7th power. This is not scientific notation. I need to move my decimal once over. We get 7.7139 times 10. That's going to add 1 to it. 10 to the 8th power.